I just don't know why it doesn't work properly. You're live. I'm live. At long last. Oh my god, now I've got to alter my internet page, haven't I? Because it now has two of these up. Nope. One messed up, so let's go and have a look in there. So, what you are seeing now is my studio, my home office, as it were. I'll take you through that home office as well, including Muppet, who's part of it. He's my mascot. So, videos. Live. One died on me, so has it recorded it? Live now, live replay, 32 seconds. No, we'll kill that one. I understand. Delete video. Yeah, 32 seconds of clunk, crunch. Right, we're live. Good. Relax. That is the most stressful way to start a stream ever. But as you can see, it looks nice. Yeah. Welcome. Let's say something in chat. What we got? And today we can finish what we started, the documentation. And then I would like to go on hope to add another set of code to demonstrate. Things. And then we head into refactoring. Oh, there's a big word. Transporting your code from one place to another. How about that? There we go. Always put it in simple fashion. Why not? Where's my coffee? Alright, what you're looking at on screen is our current test demo. I'll stop the test demo so we can see the screen. There it is. Okay. That's the correct colours now. Good. Press any key to continue. Yeah, you didn't think that was my desktop, did you? Exactly. But it is. That's the picture on my desktop. As you can see, I had a 3D cube spinning around on my desktop without any background. Interesting. So why isn't... Yeah, never mind. That's a rant. Why isn't the desktop already 3D? See, you can tell it's my desktop. It does that. That clock, by the way, is not on the wall. That's on my desktop. Yeah, it's confusing, isn't it? On the left, we have my microphone, Muppet the cat, my bass speaker. There's a speaker hidden there, if you can just see it. Speaker hidden there, which you can see. Fantastic microphone system, by the way. It's a shout out to Focusrite. Cost me, I think it was £120. Good piece of equipment. Very good piece of equipment. Works beautifully with OBS. It's plug in and play on Linux. You just plug it in, you switch on OBS, you dial yourself back to about -5 decibels and put your speaker volume to 2/3. Bob's your uncle, let's go. You've got monitoring on the Focusrite little thing that you plug in. It's got all its little whistles and buttons and things. This keyboard is for this monitor and this monitor, which is Linux. The mouse is at the back because I had Muppet sitting here at that point. As you can see, that's where we're up to, stage 6. So this was taken at the end of yesterday's stream. There's the stream, there's OBS, there's Discord, and I'm in the wrong channel. My apologies. I should be in Amber Skies right now. General. Has that put me in? Yes, it has. Am I sounding? Yes, I am. So I'm now talking in the general chat on Discord, and it's working. Yeah, I'll just close my voice off in case somebody joins it by accident. My glasses. Yeah. What else we got on this screen? Oh yeah, it is a 40-inch, told you. It's a 40-inch Philips. Rubbish, absolutely rubbish sound, which is why I have the speakers. That is brilliant, brilliant display. Just don't bite for the sound. It is a monitor, it is not a TV. This little TV has better sound than this. And this is where the Linux sound comes out of. So if anything comes out of it, well, it actually comes to my headphones now. I've processed it through there. Underneath the desk we have another keyboard, which you can just see here. That's for the big screen, which is Microsoft. That's the Linux machine just poking out the back. It's like a T situation. The Microsoft machine goes across because it's convection cooled. So all of that area there where the cat is hot air going upwards. I've got a feeling it's going to warp the desk. But hey ho, if it does, it does. It's only a cheap desk. So yeah, we have a God knows what size screen here. It's the old TV from downstairs. That we got a new TV. So this one came up here. I have 2 monitors behind me on the floor. Yeah, which I used in the old days. But that is 4 times the size of that monitor there. So that's 4 screens. And that's 2 screens. So I've got 2 screens and 4 screens available to me. And when I'm programming off-air, they are all full, but not of on-air stuff. These are full of code all over the place. As you can see, I've got sticky notes. And I have repos going out of my ears. I'll show you. Because I was looking at them today. So I'm actually looking at the YouTube test repo right now for later on during this video or this live session. I'm thinking of just writing some of that into our code. But if you want to know how many of these I've got, repos. How do I get to it now? Is it back arrow? YouTube repos. I've got all of these downloaded. Some have multiple things in them. So that's the exploration. So these are all the repos from the YouTube videos. Plus I've got a development one which I've got for myself here, which is the dev one, which I've been messing about with at times and really got quite far. It's not been too bad. But I'm just having a look at that one there. It was that one. I'll pop that back over here. Do I need it open? No, not really. So yeah, there we go. Where's the code? Oh yes, I remember now. We're supposed to be doing coding on this channel. Anything I've forgotten? Oh yeah, I've got a server. You can just see the light there. It's a HP ProLiant Office server. It cost me, what was it, 7 years ago, about £400. Yeah, about £400. So it costs less than a full PC, like a low-end PC, even in those days. I don't know if they still make it or not, but it's a fantastic little server. It runs my online, my Ultimate Online. It's on all the time, 24/7 for it, because I do have other players to contend with, as it were. And they always want access, so the access is there. There is a keyboard and a mouse specifically for that, so that's down the bottom. So I've just pulled that up and I can switch this TV over to that, to monitor that. And there's a keyboard and mouse to replace this keyboard and mouse. Yeah, that's how it goes in this house. Mail's always open. I had some mail. I had a comment on, I think it was the Ultimate Online number 3. So there's some mail there and a reply. If you want to go and have a look. I think that's really all there is in my office, except for my office chair, which is very, very comfy, and the fact that I can't show myself because my clothing is fluffy stuff due to my condition. Basically, I have cross-wiring in the brain, which makes my pain receptors in my skin go absolutely berserk. So anything that touches me is painful. And that includes clothing. Everything I eat is painful because it goes inside of me and touches my internals. It's lovely. Breathing is painful. My heartbeat is painful. What can you do? Ignore it. Get on with life and quit your job because you have to. And do something positive. And that's what I'm here doing now. I'm trying to make what you see on screen right now. I want all of those screens to be showing 3D desktops. That is my goal. I think we deserve it nowadays. I don't think we deserve this half-cocked programming that Microsoft shove out at us and mess our computers up with. I don't run drivers on these two, by the way. There's no drivers in operation there. They're absolutely fine. On this here, I've got drivers galore, and it isn't absolutely fine. I need an ice. This is it. This is my whole point. That's Windows 10 with a beautiful background, which I took a screenshot of last Sunday from the Naval Action game. Watts was playing it. And I actually have a Core i7 so that I can run Windows. The operating system is on a solid state drive, an SSD, so that Windows 10 can handle itself and that the processor has enough information to be able to run at the right speed the whole of Windows 10. Over here, I've got an ancient i5 computer which I bought 6 years ago now, that cost me 6 years ago would have been around about £780. So today would be in the range of about £500 because of the devaluation of the chipset. But it's an old i5 and it runs at the same speed as this. These two systems run at the same speed. I get a window up on Linux, click, like that. We're just running that, weren't we? Yeah. So, it's exactly the same speed. Yet, if I use an i5, this computer that you're now seeing as my Windows machine, it chugs along very slowly. And it's not because of the programs that I put on it, it's because of all the lovely, helpful programs that Windows and Microsoft put on it. In their niceness to humanity, because they can't be bothered programming it properly. Yeah, we're up to part 6. Ignore Microsoft, I don't want to rant about them. I actually approve of what Microsoft did, I just don't approve of the method that they used and what they did to the industry in their aggressive marketing of Windows. I don't think that aggressive marketing has helped the development of Windows at all. In fact, it's hurt it very badly. We're still in 2D, for God's sake. Right, this is a program that puts the 3D cube on the screen, by the way. And we got up to create shaders now, GFX card. Did we get that far? I thought we got up to part 6, the API. Yes, we did. Now I'm sure. Right, So what we got? We've got the storage for the vertex array object. That's just a number. All our graphics card is going to give us is a number. So we ask the graphics card. That's not a board, it's a card. Come on, Blades. Get it right. Oh, have I advertised? Hi, advertising Amber Skies, Patreon. Like, subscribe. There you go. Advertisement's over. Ask for ask the GFX card to reserve a memory block, the number of memory blocks that we need, and the address of storage for the identification number. And it is an identification number. Literally, it'll be probably the number 1, because that's how our card works, or our graphics card works. It doesn't go in for fancy things. It's just basic number 1, which is why it's an unsigned int, by the way, because it has to be. You can't have negatives, so don't make it an int. A lot of people just put int there. Don't make it an unsigned int. Do it properly. Don't be lazy. Let's have a look. We're binding it now, so switch the graphics card. Press the switch on the graphics card to use a vertex array memory block with the identity, and that's the identity of the memory block, which it's just given us. So now it's going to know which one we want it to use, because we could have had others before. This is just the first one, so that's all. As you're going to see down here, we'll get more as here. That's for a VAO, vertex array object. What does a vertex array object do? It records what we do next. So now switched it on, it's now in record mode. The graphics card doesn't tell you all of this. It expects you as a programmer to know how a vertex array object works. And what the vertex array object is going to do is it's going to list out all of our VBOs by identification number, probably 1, 2, 3, 4, 5. Well, actually, no, it isn't. It starts at 0, so it goes 0, 1, 2, 3, 4, 5. So the first VBO is going to be 0, and it's going to be recorded in our array at the 0th position. It's an array, just like any other array you have, or vector position. You know, it's actually more of a vector. No, it is an array. It only has 32 spaces on it. Yeah, I think it's an unsigned int array of 32. I don't know if it's 1-dimensional, 2-dimensional, 3-dimensional, because I never looked it up. And I don't really care, because I haven't got any control over that. So that's what that's doing. That's recording what we do next. What we do next is we generate a buffer. So it records the fact that we have asked the board to reserve a memory block, the number of the memory blocks that we need, and the address of storage for the identification. Well, it doesn't. Actually, it does. It takes that address and the identification number, pairs them up, and puts it in whichever storage location it's on. At the moment it's on 0. So that position VBO will be recorded under position 0 in our vertex array, and all the information that we now put in here is also recorded here in our vertex array. This is important later on, because when we come to render, all we have to do is say to our graphics card, use this vertex array information, and it will do all of this information for us. So it's a shortcut. You're making a macro, an OpenGL macro maybe? You could think of it like that, that does all of this work for us before we render. It throws all the switches that we need switching on, and then it'll switch them all off afterwards if we ask it to unbind the array. So it's learning what we're doing. So that's what we're doing. Run a VBO, a vertex buffer object. This is literally a block of memory full of data. We bind it and we tell OpenGL which type of buffer we want, an array buffer, vertex array buffer actually, because it's a VBO. The identity is a memory block, yeah. And this sends the data to the card. After this point, the data we don't need in memory anymore. We could erase it, but I don't. There's a reason for it, because I would just want all of this straight on that array. I don't want any messing about recorded on the array. So here, transferring the data, what does the graphics card need to know? It needs to know the type of buffer, the number of bytes of data, the address of where the actual data is in computer memory, and we give it a hint, not a command, a hint of what we are going to do with that data. Normally we choose static draw because we're not going to change the data, and we're not changing the data on the graphics card. So OpenGL enumeration, giving the why don't I just do that? Oh, there we go. Enumeration, giving the graphics card an idea of how we will use the data, an idea of, a hint. We don't have to stick to it. We can break the rules. We don't care. And then what do? We switch it on. And that is the last thing we need to do, is it? No, we have to tell it what to do with that switch. So we tell it that that data is going to be processed in our shader on our layout position 0, which equals the positions. That's the 0. If you go and have a look at the shader, it says 0. I've got the shader here. No, the shader's not on there. It's in resources. Here I put the shader because I did a new one. Here we go. Open with K. Always opens on a different screen. So layout location 0 is our position. So that's the vertex shader. And layout position 1 equals the colour, as you're about to see just coming down here. When we get to the colour, we're having a uniform MVP. We send the colour straight through to the fragment shader, and the position is multiplied by the model view projection matrix and gives the position on screen. Basic fundamentals of shader languaging, and you can see it's hash version 330 core. Close that. Thank you. Just a little. That has to match. That has to match. If it doesn't, you're in no man's. I nearly said sky then. You're in no man's land. Oh dear. There was nearly a Freudian slip there. Ah dear. So now we've enabled it. We tell it all about the data, how we want it to handle this data. So we're going to tell the graphics card about this attribute, this location layout 0, and how to handle it. So this is which attribute we are referring to, 0. 0 equals positions. 4, how many items we have. Is it? Just put a comma there. Glint size. Is it how many items we have, or is it the size of one item? Now the size, the total size is down below. It's one of the two. I think it's how many per thingamadoodle what's it face. I think it is. If I'm wrong on that, say so in the comments below, but that's what I think it is, or that's how I look at it. It's how many items we have, like A, X, Y, Z and W we have 4 positions. As you saw by the shader, we have a vec4 for positions. We are taking them all in. We're even taking in the homogeneous position at the end. Or homogeneous. How do you want to say that word? In England, we say homogeneous. In America, we say homogeneous. Or homogeneous. I'm not sure, because homo just means individual. Doesn't mean anything politically incorrect. So get used to that one. GL float, OpenGL enumeration telling the graphics card the type of data, because we are using floats. GL faults, do we want the graphics card to normalize our data? This is a talking point. This is something that everybody else skips over. This value is important. Very, very important. And you'll see everybody just say, oh, just put GL faults in there, it'll be okay. And they don't really explain it. If we normalize our data and we've got a vector of 3 or 4 points, which we have an x, y, z, w. If we normalize that, then the length of that vector will become a unit size of 1. That's what unit size means. In other words, it will adjust all the values that you send, all the values that you will send in, it will adjust so that the Pythagoras theorem, when used on it, equals 1. So x squared plus y squared plus z squared plus w squared, all square rooted, equals 1. And that's what they call a unit vector. It's not a complicated idea. And on normals, when you are sending normals in, it gives you the ability to normalize them when you're sending them in. And you'll see a lot of people normalize their normals inside the fragment shader, which runs a bazillion times more than your vertex shader. But you could have normalized them when you were sending them in. You could have had your data being altered as it was entering the card at lightning speed. So why do we not do it there? Because people don't understand what that line means. So GL faults, I'll just say what everybody else says on the internet. Just ignore it, put GL faults. Why not? But at least I've given you something to think about and discuss, if you wish to. Comments are open here. I'm live. And if you're watching live and you want to say, but, that's what they don't say that on other videos. No, they don't. I don't care what they say on other videos. I'll tell you the truth. There is a special set of circuitry on your graphics card which does automatic normalization of up to 4-dimensional vectors at lightning speed. It's designed to do it. Why not use it? It's there. People don't. And then they complain, oh, my graphics are running slow. Well, yeah, look at your fragment shader. It's normalizing every single normal. God, what are you doing, man? Or girl. Sorry, that was a colloquialism expression. What are you doing, man? It's not meant to be sexist. Anyway, enough of that line. I told you I was going to stop and rant. I knew it would happen. The next line is the total size in bytes of one item of data. So it is the size of a float times 4. Yeah. In bytes. And that's the equation for it. That's how you get bytes. The null pointer at the end could just be 0, really. A lot of people online will put a 0 in there. Don't. If you ever finish a GL command with 0 and have said online that's what you should put, they are wrong. absolutely wrong. Null pointer on this machine means 0. Null pointer on your machine may not. I'm on Linux. You're on Windows. Windows can screw anything up, especially a null pointer. So don't put 0 at the end. Put null pointer, because have a look at that. It's a standard library null pointer underscore t type. Underscore t means type. So the standard library will give it the value that it's supposed to be. Not us. Not the operating system. And especially not the IDE that you are using, the integrated development environment that you are using to develop with. Put null pointer in. Then you know for certain that the correct value will be passed to OpenGL and your graphics card. You put a 0 there, and you're using graphics drivers, you're wrong. Think about it. That's portable. 0 isn't. I mean, there's more than Windows and Linux contend with. They aren't the only two operating systems in the universe. We've got Macs to do as well, when I can afford one. Oh, good news. I think next Tuesday I might be up to £500 towards a Mac. Yes! And that's without help from Patreon or support. I am really scrimping and saving. I'm down now to £30 a week spending just to do this, just to be able to get a Mac. I know it's sad. I need 1,500, so I am a third of the way there. So I expect to get a Mac this year. Oh, that'll be fantastic. I've got screens and stuff, but some of them come with screens, don't they? I don't know which one I'm going to get yet. Oh, God, I'm looking forward to that. I've always wanted to play with a Mac. I've always wanted to be on a Mac. I've always wanted to use one because they say, oh, gaming's rubbish. The word BOLLOX comes to mind. Gaming isn't rubbish. It's just that people don't have Macs to write games on. Or they write the games for Windows because they're stupid and don't realise that you can generalize all of your graphics code to work on any system, which is what I'm doing here, and I'm proving it. This is my poke at the gaming industry and saying, oi, guys, you got it wrong. You've fallen into the trap of Windows. Ha! Muppets. Yeah. Right, what are we on now? Oh, yes. We're on the next VBO. So we've done the position vertex buffer object, which is just, as we've discovered, a block of memory on your graphics card. So we're going to do exactly the same for the colour. All of this gets registered by that array that we started with at the top. So we get the full colour VBO, and it's exactly the same. The only difference is these zeros turn to 1. So we want one buffer. We want number 1 as the attribute, and which attribute are referring to number 1. And on the shader, in your shader, number 1 equals colours. And it does for this version. I've got to change this when we refactor, because it won't. It'll be number 3, because I'm using a different shader. Yeah, there you go. I don't know which shader I'm using yet. I've just had a look through and I don't know which. So all of this is exactly the same. So every single VBO that you want to use, which is, in our case, positions, colours, and that's it. Those are the only two that we use. The index VBO. Now, stop, talk about. Storage for the index vertex buffer object identification. It looks the same, doesn't it? We're generating the buffers the same. It's just to reserve a memory block. We do everything the same until we get to here. My cat's snoring. Oh my God. Cat's on the floor next to me. curled up in a little ball, snoring. Isn't that ace? Oh, bless. I've got no drink here. What on earth is a GL element array buffer? It's a special buffer. You can only use one GL element array buffer at a time. You can't have more than one. So as you can see, it's looking a bit different here. What happened to all why isn't this number 2? Why isn't this an attribute number 2? Because it's a special buffer that holds all our index numbers, and our index numbers, oh god, how can I put it? Because we generated them ourselves, didn't we? If you remember, from yesterday, we actually generate the index numbers ourselves. We didn't get them from anywhere. We made them up, so we know what they are. But we're now putting those on the graphics card into a very, very special buffer, which we use as our way of drawing all the rest of the stuff, or how we draw, or in which order we put the data through the shaders. That's the best way of putting it. It isn't actually an attribute in itself. All it says to the graphics card is, this is the order that you use the data in, and that's what the index is. So it could be 1, 2, 3, 1, 5, 7, 8, 10, 2, 1, 5, 7, 6, 1, 2, 4, 5. You get it? It can put them in any order it wants. Oh, sorry, we can put that index in any order we want, so we can control how things are drawn on the screen, and that's important. Because if you go around a triangle to the left, in other words, 0.1, 0.2, 0.3, 0.1, and you go around it, that's anti-clockwise, isn't it? Counterclockwise, I think we call it. Counterclockwise, yeah, CCW it's called, is the abbreviation. We can specify that to be the front of a face. And when it comes to clockwise, or the back of a face, we can say, don't bother drawing it, just ignore it. It'll just drop it. It'll just drop it in the fragment shader and won't do anything with it. It won't even probably make it through to the fragment shader if it's going in the wrong order. So that's doubles the speed of your rendering automatically, just by thinking about something like that, and your indexing, and in which order you draw your vertices. Yeah, so that is a very powerful line, that. And what we do here is we just send all the information to the graphics card. As you can see, it doesn't specify that it's an attribute. On to part 7, rendering the object. In part 7, any questions? Any questions? I'll drink some Coke and wait for any questions in chat. Don't worry, part 7, we're nearly at the end. As you can see, it says private in application below. Now we can get on with some fun stuff. Black bubbly burpy liquid. Where would I be without that stuff? Right, what do we got here? Part 7, rendering. Yeah. This business of matrices, all of this is setting up our model view projection from here down to here. That's our model view projection. What is a model view projection? You have your model. You place it in the world at a place and a rotation. You then have a camera which views that location, and then you have a projection from your screen, this thing that you're looking at, in the view of the camera, viewed from the camera's point of view. Yeah. Oh God, how does that sentence work in English? Doesn't, does it really? Oh, wait a minute, I've got a reply. Oh, wrong mouse. Here we go. What Emily? Oh, right, yeah, okay. Reply. Got a chat going here on one of my thingies. Reply. I use the serve. The question is, what emulator do I use on my server? Why does it put mousepad? Wait a minute. Cancel. Do reply properly, Blades. Come on. Oh, right, that's an at. Right, at mousepad. I use the serve UO emulator, but slightly self-modified. Very much so, actually. With the agreement of the player involved in designing it. There we go. There we are. I've replied to you. I don't mind. I'm going to keep this page open. Back to here. So it's a complex thing, really, because it's all the wrong way around. As you can see, when you multiply matrices together, you have to do it backwards. Otherwise, it doesn't work because of the way matrices multiply. There's a place called Khan Academy. That's KAHN Academy online. And if you look up matrices, they have fantastic videos all about it, better than I could ever say or do to help you. I understand matrices because I did A-level maths, which is advanced mathematics in England. And I have a very good understanding of them. I know that we have used row major matrices in the code, but I also know that OpenGL uses column major matrices on the graphics card. So I know that all of these matrices and calculations are wrong. They're all the wrong way up. if you the 90 degrees are the wrong way up. I better just close that, otherwise it'll won't notify me. Okay. Put my other bits up. Here we go. Hi peeps. Back on the right thing for the chat here. Matrices in general, you've got a choice. Learn about them, master them, and use them fully, or go with something like this, which has full explanation of what's going on, and treat them as a black box. And if you treat them as a black box of magic numbers, that's okay. That is absolutely fine. You should never delve into them unless, and I mean only unless, you want to become a mathematician and you want to become really skilled at manipulating matrices. And, well, to me, it's second nature how you do matrix mathematics. I mean, it doesn't matter. It's just like counting to me. There's no problem with it. I've got an empty head that can cope with it. So the first part, we do the model. The next part, we do the view matrix, which I just set to 1. That's the way you set a matrix to 1. You call it an identity matrix. So that times any other matrix doesn't affect the matrix calculation. It's like multiplying any number by 1. So if you have the number 2 and you times it by the number 1, it's still the number 2. So that's how that line works. That line works by getting a projection matrix from our window, and our window kindly makes one for us and sends it through. The reason we have that is because our screen isn't square. It's huge. I think it's 5 by 9 or something. I don't know. 9 by 5. 9 by 5. I don't know. It's width and height. It's got an aspect ratio. That's what I'm trying to say. So that aspect ratio has to go into a matrix, and there is a way of doing that easily in the window, using simple instructions, and it'll all do it for you. Produce a little black box, and you just transfer it through to here. You just say get the projection matrix, and it comes through. So that is an actual value. If I didn't have that, what would happen is this box would go squish, because look what happens. Aspect ratio. Okay, if I drag it out, you can see it's slightly stretching. It's altering its shape using that matrix. If I bring it right in, it's altering its shape using that matrix to fit the window shape. It's not doing a very good job, must admit. If it's a square, it's alright, but if it's at about 5.9, it's also it's spot on when it's at the correct size for your screen. I know that because I did all the calculations, but I do need to redo that because I don't like it squashing up like that. Just pop you out. Thank you. Thank you. Right. So that's where the get projection comes from. It comes from your window class, which is using GLFW in our case, and GLFW has a nice way of doing it, so that's one of the reasons why I use it. There you go. I think SDL does the same kind of thing in literally the same way. At the end of all of that, you just multiply them all together, and this here, this variable here, stores the location in the shader for the variable that we name. So the shader program to look at is our program ID, and the variable name to find within that program is UMVP, and you can do this at any time you want. You don't need to do that before linking. I think I mentioned something about the linking problem with the page layout and location system. You can't do that after linking, but for some reason MVP location will work after linking. Go figure. The reason is it puts it into a separate and special place when compiling, so that into a lookup table when the shader is compiled. The compiler builds a lookup table for uniform variables because they are treated differently, because that's per run rather than per vertex. I should say per draw call rather than per vertex. Here are test variables for rotations of x, y, and z, x-axis, y-axis, and z-axis. I'm going to show you something in a moment which is going to blow your mind. In our application, all we're doing is a while loop as normal, so it's just a big while loop, and we do all of this. So what are we doing? The usual, we prepare the application by clearing the screen. Remember, this happens on the back buffer, not the front buffer. You put that into your mind quickly, because if you've got the silly idea that, or sudden you've got the idea that it's altering what people see on the screen, it isn't. It's altering a second buffer, which is the same size as your screen, but behind it. So it's called a back buffer. That's the best way of putting it. So all of these operations are on the back buffer. So we clear the back buffer, or clear the screen, so it's blank, so we can start again. We then redirect one of my tests for IMGUI, GUI should I say, and then we do stuff. We create a new model matrix with the rotation test variables. altering the rotations. We don't alter the position, just the rotations. We then have to recalculate the MVP, obviously. We then set the value as the uniform variable for this run. To do that, we set the value as the uniform variable for that matrix 4D, the MVP. The location of the variable in the shader program is that location we asked for earlier. The number of variables, just the one, please, just one. Transpose to column major order, true, because we are in a row major order. If you write your own maths library, it's your choice. I prefer my maths library in row major because it makes more sense to my head. My head breaks if I try to do mathematics in column major. Don't ask me. That's just the way I am. It's up to you. If your maths library is in column major, like you're using GLM, which is available online, which is the OpenGL maths library, you know, then it'll be in column major order. So you put faults there. And the last piece of information is the start address for the data. And that's complicated because it depends on how your data is stored. Mine is in row column, so it's row major. Yours might be column row, column major. But that's the first location in the address MVP. Because if you have a look at MVP, I'll show you actually. Because of my maths library, MVP dot has row, so it's row 0, row 1, row 2, row 3. We can rotate, scale, we can do quite a few different things in there. We've got orthographic and perspective in there, and I've got the identity matrix as well for times it by 1, which is useful. So it's got a lot in that maths library. But I had to write out every single one of these. And if you ever go and watch that video, I will never write them out again. I will use what I've put there. I'll just copy and paste and stuff it. There you go. You only have to do it once. Just write it out once or use somebody else's library. Simple. For me, I wrote it out once. Now comes the biggie, draw elements. And draw elements uses our index buffer. So, draws using the element array buffer as an index source. So you now know why that index array was, that index buffer object was a bit different. It's special. We're going to use triangles because we can't use quads. I found out if you look it up online, GL draw elements and C++ doesn't handle quads, which is what the intention was of all of this, was to draw quads, and it didn't happen. I had to change it back to triangles. OpenGL enumeration that switches on 3 vertices per face, that's correct. Tells the compiler that we mean to use a variable type of OpenGL size integer. Yeah, I don't understand why we have to do that, but we do. And that gives us then the index array size of the index array. It's because this comes back as a funny thing. Size, there you go, it comes back as a size t. Unfortunately, OpenGL doesn't like size t, so I had to recast it into a GL size I. Which was a little bit annoying. I could have done without that. So that line is just to help the compiler realise that that has to change to that type. It's an extra line which I disagree with. So the size of the index data, that's how big it is. Here we give the OpenGL enumeration for the type of our data, which is GL unsigned int. That's what we're using for indexing. 0 to whatever, 1, 2, 3, 4, and a null pointer again. Where to start in the data buffer? Null pointer equals start at the beginning. 0 doesn't. But a lot of people online will put 0. Don't do it. Don't be fooled by whatever they say, that it doesn't matter. It does. If you want to make your code portable across any operating system, it matters big time. There are very, very old operating systems out there which are still using a null pointer as a -1. Yeah. I'm just not going to say anything there. Dear I'm GUI, we draw a window. I'm not going into that lot because I don't know too much about it. I just, as you know from yesterday's video, if you've watched it, I just cut and paste that out of the example that they gave, and it worked, so I've left it alone. As you can see, there's not much notes on it. I don't know much about it. That needs investigating more. So I only note things if I know what I'm noting. There's the I'm GUI render. So all of this lot should really have gone before our render. So this is our render. We should have then had I'm GUI render here. But I didn't put all this rubbish in. Never mind. Put it on the screen for a sec, just to make sure you can see it. So it's dear I'm GUI, blah 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 blah, static floats begin, big time. That's how I'm GUI starts. Then you put a load of instructions for the window, and then you put I'm GUI end. This is not needed. You can take that out if you need to. Don't want it in. But that just means it's in its own instanced block. So everything, any information that has been passed through to the graphics card, because that's what it's doing, it's passing all this information through to your graphics card. Any information that's still in memory gets wiped out there. Variables or whatever. That's all that makes sure of. Then it renders. Update the application. Always do an update. I'm not sure if that line should be there. No idea. Needs investigating. So it hasn't got a comment. That's my line, window update. So this polls events, that means it checks the operating system for keyboard and mouse events. It also swaps your back buffer to your front and your front to your back. So you can start again. And at the bottom here, all I've done is added 1 to the number of degrees of rotation on the box that we're drawn. But there's something interesting happening here. Both of these say +1. So in the X direction, it's tumbling towards us. In the in the X axis, the one that goes across the screen, it means that it's rotating around towards us, straight at us. I can show this just by... I can show this better if I show it properly, can't I? So let's just comment those out. So if I comment that out, the X rotation is the X-axis. Let's get the X-axis up on screen. Come on. Rotation around the X-axis. And I want you to watch carefully. So, that's what I'd expect. That's spot on. That's the X-axis. The X-axis goes from the center of the screen, minus to the left, plus to the right. So that's your X-axis that goes across the screen. And of course, the box will tumble towards you from the top. If you minus, it'll do the reverse, obviously. But what that means is, if you take your right hand and stick your thumb in that direction and you curl your fingers around into a loose arc, your fingers will show the direction of rotation, as that is a right-handed rotation. In fact, if you do the same with your left hand going negative, it would do the same. But then your thumb is pointing negative and not positive. So put your thumb in the positive direction and you'll find out that that is a right-handed rotation. And that's because OpenGL is a right-handed system, which is counterclockwise. CCW. Very important to know. those little facts are very, very important. And I mean very important. 1. OpenGL is right-handed. 2. OpenGL therefore is a counterclockwise system. Positive is always anti-clockwise or counterclockwise. Negative is always clockwise. Put that on a post-it note on your desktop. Put that information up. If you ever want to program 3D, put that on a post-it note, stick it on your desktop for later reference, because that will save you hours and hours of heartache. Bing. Now, what's going to happen then for the Y rotation? So what we're going to do is just bring that back in, that selection. Sorry. Okay, which way is the Y direction? Can you tell? So, Y-axis. Which way is the Y-axis? Well, we're about to find out. Oops. Let's run it. This is a very, very good program to play with. I must admit. There you go. The Y-axis is positive up, negative down. The Z-axis, by the way, is positive towards you and negative into the screen. Yeah, great idea there. Now, if you put your thumb in the positive direction and curl your fingers slightly, you will find out that it is rotating in the correct direction for your right hand. Counterclockwise. That's interesting. So if you add those two rotations together, what do you get? You get a 45-degree rotation where positive is there across from the corner to corner. So your positive would be from that one added to that one, would go to the top corner, you put your thumb on it, give yourself a little curl on your fingers, and you will see that the rotation should be diagonally downwards. Does that make sense? I hope it does. I really do hope it does. So we're expecting it to go downwards. Okay. So let's go back to our code. I'll take that out now. Bet it bloody works now. Just to call me a liar. Now, oops. Don't press all the silly buttons, just keep it as it was. Cute. Oh, I've got the burpees now. Hey, it's working. What do you think is going to happen? I'll give you a big box to watch this time. Is it really doing the right thing? And why? Come on, can anybody, if anybody in chat can tell me why it's doing that, or what it is actually doing, because its rotation is 100% correct, although visually it's doing the wrong thing. Now, let's take a step back and look at what's going on here, because this taught me something. This taught me something remarkable, that I was stupid and I was ignoring something a little bit more than I should be ignoring. I was ignoring where is the center of the box. Around what point are we rotating? And that's your clue to understanding what it's doing. The point of rotation on this box is incorrect. So when I drew it in Blender, I put 0, 0, 0 in the wrong place for it to be able to, well, act properly on screen. So I've got to go back to Blender now, redraw the box, which isn't hard because you get it given freebie, and put it in the right place and save it out again. Yeah, that's all I've got to do. It's nothing to do with my code. Code's fine. It's just that I never had in mind a problem that we now have, because I positioned it wrong. I'm just trying to find out the one that you should watch. I think it's one of the red corners. Get back on the right mouse. So what you need to do is pick a corner, and it is the next red one coming up. Here we go. Here we go. That corner there. Where's it going? Comes back. It's doing a figure of 8. Comes over, does a little figure of 8 at the end. That's the giveaway. And then comes over again. So it's that little figure of 8 there. That means my center of, well, my center of the box is off. It's here somewhere inside the box. You can tell by that one corner doing that little loop of 8 around it. So it's got a big loop and a little loop. So it's going in the right directions for what I gave it. It's doing a torus. A twisted torus. It's doing the movement of a twisted toroid, if we want to get mathematically correct, I guess. But that's proved something to me, that I can't always get it right, even though the code is right. I know the code is right because it's simple code. It's not doing anything stupid. As you can see, when they run one by one, it looks good. As soon as you run them both together, it shows that the origin point, or the point about which I am rotating, is wrong. That's what it's saying. Now I don't know, or I can't remember if it's something to do with that or not, but there's the rotations. Yeah, it's doing it in the right order. You've got to do these in the right order, by the way. When you're creating a model matrix, if you create it in the wrong order, or the reverse order, everything comes out weirdly. And that model would then rotate around the 0, 0 of your universe. And it will just do weird stuff instead of rotating around its own point, or its own origin point. But that's a different story. So you get orbitals. All you do to get an orbit, by the way, is reverse the way that you make the model matrix. Yeah, that's how you do orbits. Right, okay. Finish documentation. Hope to add another set of code. Do we? Have I got another set of code here? I think I have. I was looking at repos, YouTube. Right, okay. So it's that one there, so it's the YouTube one. I'll just stick it with K. There we go. I'll pop that to one side because there's a lot of information in there that we don't need. Okay. What I'm going to do is I'm going to try and add something that won't work. Interesting. File, open. There's no dev area. Standard main opener. Here we go. Right. What we're going to do is I'm going to do some additional code. So let's get some space for it. I know this is getting a hell of a long piece of code. Right. First of all, look at all of this lot here on the right hand side. Can you see that lot there? Yes, you can. It's on screen. Right. On the right hand side you can see a miniature view of your code, and there's a lot of lines. There are 965 lines. The piece of code I'm looking at is 93 lines, 1/10. But I don't know what it's going to turn into. I really don't. Okay. Let's make a variable. Because I want to put this by itself. Or back up at the top somewhere. So, window. Application. Here we go. What I'll do is I'll just put a bool in. Bool, and we'll call it extra stuff. Okay. We'll make it equal to false to start off with. I'm just wondering, yeah, because we can run both by the same. So if extra stuff, just make it better. What do we want to do? We want to do a function, and what we're going to call it? Extra stuff. No. We'll call it comparison stuff. Make it into that. We'll do that. We'll take U, copy, go right back up to the top because I need to be at the top for this. Because I don't know what includes it's going to need. I'll just pop it here. Yeah, that'll do. And it's going to be a static void. There you go. You okay with that? Yeah, you're okay with that. Right, so I've got this to write in. Excellent. Let's do some coding. Yeah, hey, what's up, man? Right, it's only just after 2 now, so I'm going to do some coding. Get myself settled. Stretch me back, because it's hurting. I should really take painkillers at this point. Right. First of all, what's the first thing I want to use? We've got a window. So the first thing I want to use is the data loader. Okay, that's going to be interesting. And do I have a thing for a data loader? Yes, I do. So we are going to make a comparison area. Just carve it up. Remember, I just carve things up in all directions. I'm not really that bothered how I do things. Okay. So up here, let's have some thingies. Hash includes. What do I want? I want to include the API. Which one is it? Is it data loader? Yeah, data loader. There we go. Include you. This is all in Amber SL, by the way, the first series that I did. You'll find all of these functions, all of these headers, and all of these files detailed in depth, I hope. I hope I did it in depth. What else will I need? Yeah, I'll take the model loader as well. Hash include May as well. We'll do it properly. So it looks like there's a lot of includes, but there actually isn't. Not for what we're going to do next. And it's model loaders, please. And I'll have OBJ. Data loader. OBJ loader. Yeah. This is a thing that I'm looking to change with all the new information that I've put in that in there. OBJ data structure now has more information in than this is using. This is not using much information at all. I think it's only about 4 or 5, just like we've done with this big program here. I've just cherry picked, what, 4 or 5 bits of information and thrown them together to make a box. Yeah, well, that's exactly what this is doing still. We've got to put it all together so that it doesn't cherry pick anymore. It actually goes through all of the data and chooses to do the right thing with that data. And that's a big difference. We have to make it slightly more intelligent than it is at the moment. What else will we need? I'm going to take the lot. I'm going to go rich. I'm going to take the camera as well. Where can we get that from? Entities. So it means that we can move the camera. Which this will change the model matrix calculations, but not on the box it won't. The box will be running on this code, and this comparison stuff will be running on Amber SL code. Just as a comparison to see the difference, see if there is a difference. Because there's lots, as you're about to find out. We'll also include, what else can we use up here? We've got tons in Amber SL. Oh, we can use a renderer, can't we? Render engine it's got. Well, I just don't need master, don't I? I don't need the other two. It'll refer them anyway. Sorry, defer to them anyway. That's okay. I want to load a model. So this really wouldn't be in this file normally, but include. We'll do everything in one. We'll do everything in one strip again like we've done here. To make it a good comparison, really. Models, please. What do we need from models? We'll take the base. We've got a model base, yeah. Do we need to include more? I think so. That's the basic model. What do we need next? Model textured. Yeah, we're going to use a texture on this model. And well, that means we're going to have to store a texture. So we're in models. Then I want to go to model textures. Then I want to store a texture, thank you. Texture.h. Thank you for that. And I'll include now, because this will be using a different shader, I can include different things. So I will include, yeah, don't have to use the same shader just because, you know, you can use any shader you want. Entities, what entities have we got? We'll need the base entity, definitely. So that's you. That's your base. What else will we need? This again wouldn't be in this file normally. All of this should be split into about 4 or 5 different files. It shouldn't be like this at all. Entities, what else have we got in here? Light we'll have. Don't want terrain? Not really. Yeah, what the hell? Do a full one. This will show up all the problems I've got to overcome. I think that's the best way of doing it. terrain. There it is. Yeah, I want to use as much as I can of Amber SL in one comparison stuff. I think that's fair. Okay, so comparison stuff goes something along the lines of okay, and I'm just trying to get in my mind a way to do it. I can't put the box on at the same time, so I'm going to have to write into this a main loop. Okay, fair enough. We'll just write it as one single long bit of programming. And is it going to be 900 more lines of programming? Well, let's see. So I'm going to change the main program now, because I know it doesn't need to go through everything else to get here. Okay. We're not putting the box on at the same time. Can I just click in a place and it goes to it? Oh wow, that's ace. So those two, once it goes to comparison stuff, after it's done comparison stuff, yeah, I'm going to have to exit. And that is going to be exit 0. Semicolon. There is some other stuff I need to do in there before I exit. We need to get above the OpenGL. And everything else is okay. Fine, yeah, that's fine then. If everything else is okay, we're happy. So we could just exit, that's fine. So that needs to get above the OpenGL. Which is... shaders, no thanks. So let's create the shaders, that's okay. I have to make sure it goes after a delete. Goes in here. Spotted. There we go. Just a reminder to me that it's on a separate exit condition. Otherwise I will forget and not realise that there's an exit 0 there, and I'll be an idiot. You know what I'm like. Right, yeah, that comes after deletes. That's fine. All this lot doesn't matter. You'll just get deleted and hang around and die. Yeah, okay. There's nothing there that I need to delete extra, is there? It's all storage, and it'll all die anyway on an exit. Yep, that's good. Yeah, that's right. This is a problem with using these exit 99s. They don't always delete everything. You should check that they do delete and restore memory. But I haven't done because it's a small program. It doesn't matter until you put it into something major. Then all of those will come out. So, comparison, back to coding. I've got access to all of this stuff. We don't need a window, we've got one. We've got a background colour, yeah. Okay, it's clear. It's looking good. So, using... yeah. Using... namespace. This is how you get around namespaces. Amber, which Amber SL is written in. Every single line of code in Amber SL is within the namespace Amber. So it's quite easy for me to access everything now just by saying using namespace Amber, so I don't have to put Amber in front of everything. I'm not sure if that's good or bad, but they are on their own namespaces as well inside each of the folders. Each folder is a namespace. So for instance, API data loader. Let's start with that. Is API PI colon colon, and it should be data. I hope this works. Is it going to catch up with me with all of this or not? Data loader should be there. Well, it should be. And it isn't. I've got the configuration correct. So API should work. Okay. Take that line out. Let's try it for real. Right, so Amber. Colon, colon. And I want API, please. API, thank you. Colon, colon. Data loader. It's fine. So it just doesn't like the using bit. I wonder if I put the using bit in wrong. Stuff here. I'll just have to use it, won't I? Right, data loader. Using Amber. Yeah, right, okay. Using namespace Amber, it just gets rid of that colon colon at the front. So we still have to do the rest. It's me trying to be lazy and not getting away with it. Let's call that loader. What the hell? Why not? That's just a variable name. So that is a class object for loading data. That's what it does. I know that because I wrote it. Next. We'll have a model loader, why not? So it's Amber. Do we have a model loader here? Yeah, we do. Which one do we want? Which one do we want? Which one do we want? OBJ. We want the class. That's that one, isn't it? No, I don't want this model loaders at all. Yes I do. This is quite complicated and overcomplicated for me. Model loaders. And then it's OBJ loader, yeah. It is that one. Sorry, my bad. What should we call this one? OBJ loader. And this class object for loading .obj data. So that's what that one does. Do we need any more? Yeah, go on. Amber. Come on, we must have entities. Am I typing too fast for the machine to keep up or something? Nope. It's because I'm an idiot. That's why they're using Amber's... I'm an idiot. There you go. Because I forgot semicolon at the end of that. Never mind. Doesn't matter now. I'm happy typing Amber. Which Amber shall I have? I'll have an entities. Let's have one of those then. Which entity shall I have? I'll have a camera. We'll call it camera. Class object for viewing the scene. Do we need to set it? Yeah, go on then. Set. Come on, what's wrong with you? Okay, I'm going to have some Coke. I'm obviously forgetting semicolons today like a numpty. Lovely, lovely. Oh, I can send feedback on YouTube about my experience with their going live button. That's going to be an interesting feedback today. I might get a little irate on that one. It took me multiple tries to get a live stream going today. That's out of order. It shouldn't take any. So, camera should be a thing now. It is. So that's okay. Dot. Yeah. Let's have that one. And I'm going to use an Amber VEC 3, which is my math library. And we'll have positive is out of the screen. Okay. So X across doesn't need to move. Y going up should be 0.5 F because we don't want to be at floor level. Unless you want to crawl around on the floor and look around your room and that's what it should look like in 3D. No. Let's go 50 centimeters up. Remember, I count 1 as a meter. And because of that, it allows me to put numbers into here that realistically reflect things around me. So there we go. Yeah, that'll do. Yeah, okay. We'll take that for a camera position. I need the window. Here it is. Window. Address? Address will do. But I need it. So if I send window through, like that, I need that. Where that red mark is. What happened here? Development, yeah. Minus one to capture. Why is data load suddenly here? I must have clicked somehow. Badly. Bye. I think it was with me clicking all over the place. I'd just messed something up. Never mind. Control V. I'll take the address, please. And window. And I'll turn that into a pointer. Do I need to? Or can I just use the window? I can probably just use the window. Okay. I don't know. Reason I need that is for our master renderer. Otherwise our master renderer won't know where to render to. Which would never help, would it? This is going to be funny. Amber. Master renderer. Come here. Where are you? Oh no, what have I done to my master renderer? I have got it, it's in the render engine. So it must be in the render engine. There. Master renderer, yay. Oh, can it get any longer? I don't know. Let's call it a master... May as well just for fun, renderer. And we'll set that up with our... We've got the address of the window. Alright, that's fine then. So I'll just call it the window. Oh, it should work with just the window. Should. And camera. I think it, yeah, that will work. So let's do that. Let's do that. That, so I don't have to do it later. You know why I'm doing it now. Which means the camera needs its own line. Nothing above it does, they're all variables. That's good. Right. So how does this work? Let's look at it. So, start here. Sets the position of the camera into the scene. That's okay. That is vector 3D from the Amber. We have got the Amber Master Library somewhere. I'm sure we have. Yeah, we have. It's there. Lovely. That note follows. That's good. So X position equals 0.0 meters. No, I'm not going to put that in. So yeah, just put in Y position. Yeah, okay. Don't really need that, that's too much information. You can suffer from that, don't worry. Sometimes less information is more. That's the end. That's the end. And so that needs a note. That this information is now inside the camera class. Is now stored. That's how it's working. So it's not evident from what I've done that that's what's just happened. What has just happened is I have sent XYZ positions to the camera class, and the camera class is actually storing that information about itself. So that's how you can use classes, whereas below we haven't used them at all. But look at what we've got already. We've already got a loader, an object loader, a camera. We've already got the camera set up where we want it, which we couldn't do. Well, we can do in this one, but it'd be a bit more awkward actually. And we now have a master renderer that knows where the window is and the position of the camera, because the camera knows where it is. As long as it knows where it is, we don't need to. Yeah, that's a theory. God grief. Right, so what do we do on the next bit? This will be... Oh, wait a minute, I should split that down, actually. I just realised. Doing this properly, aren't I? I do need a break. What time are we on? What time are we on? We're at 1 minute 41. Yeah, I can take a 7-minute break, couldn't I? Yeah, okay. Alright, what I'll do is I'll just take a 7-minute break. I'll just set that up. There you go. I won't put it over the cap. Right, okay, I'll be right back. I do need fresh coffee. I know I've got bubbly burpy liquid, but you know, can't be on that all day. I'll be burping. If you're wondering, is this going to be a long stream today? The answer is hell yes. Give me 7 mins. Hey, Bargum. We're back. We're back, and that's. Oh! Yeah, we found the chair. We're nearly back in the chair. Wow. God, that's always the hardest part, is getting back into my chair. Get that off the screen, you. Okay. Back. Keyboard. Brew. Oh, yes, coffee. Code. Ding. Where are we up to? Oh, right, okay. Master renderer is set up. Okay. That's a class object for drawing to the back buffer, because that's what it does. And this is which window to draw to. And let's do this part properly. From which viewpoint to draw. That'll be. Oh, God. Sorry. That becomes important later on when I might decide to implement shadows. Because that means you have to take a picture with a second camera from the point of view of the light source, depending on how many light sources you want to check. So it can get complicated, but at the moment we're keeping it simple, because I am. So we've got our master renderer. Now comes the fun. So let's go to Amber again. On the right keyboard would help. Don't put it on there. Don't say it in chat. Yeah, having two keyboards in front of you, confusing. Right. Oh, what do I want? I want the model base, don't I? We are going to create a model. So let's take the model base. We got it. It will be models. Yeah. So we have got models. We have a model base. Good. What we're going to call it? The model. I don't know. What have I got? Models at the moment. I mean, I did prep for this, so what did I prep? No, not in repos. Come into the project. I prepped body and head, so we can have either. I'll have head then, because it's got more vertices in it. I'll keep that open a second. Somewhere. Bless. Because I only forget. So, what we got? The model. Yeah, right, we've got the model. Let's have a look. Let's call it head model. Okay, because we can. Equals, and that will be our OBJ loader. And this is how it looks when you put classes in. Our OBJ loader, and it's going to be head for the head. That has to go in quotes though. because it's a word. It is head. Capital letters, yeah, H-E-A-D. See it on there. And we'll need to use the loader, whatever loader we've got, which is already done for us. Excellent, thank you. So what we're doing there is we are an object loader which doesn't want to work. Class object for loading.obj data. It's there. L-O-A-D-E-R. No, that won't work. We need to use a function. It's a class, isn't it? That's not a class header. That is a dot. Load obj model perhaps might help. Like that, maybe. At least they tell your object loader which type of model to load, because obviously there's more than just .obj models out there. There's tons of different categories that we could do, I suppose. Let's give it a texture. Yeah, that won't know where to pick it up from. Wow. Just thought our load obj model is going to be wrong. It doesn't know where the file is. I'll check on that. In fact, we'll check on that next, because it matters. It'll be the same with the texture, won't it? Because this is a different setup from the original. Right, so we now have to check these. So this function here, function to load dot obj type 3D models. That is the name of the .obj and .mtl files, because remember there's two files, so it's there, and loader just loads the data. Class for loading the data, because you can have different data classes as well. Thank you. That's fantastic. Where does this all get thrown to or stored? Don't know, because it doesn't say. Amber models, model base. It gets stored in model base. Yeah, I know how that works. Data goes to the graphics card. Yes, GFX card. And the identification numbers are recorded in model base. The model base. Model base, I think it only holds two things. It holds the the identification and the index number, or something like that. It'll hold something or other to keep track of the model, but it doesn't need much. All the data goes straight to the graphics card. We're not messing about. That's all done for us. That's like zing all the way down there in a couple of lines. Yeah. Right, we've got a model. Does it have a texture? I'm sorry, it's going to bug me. If I don't go and look at it, I'm going to be in trouble. So we're looking at object loader. Object loader is in model loaders. Okay. So go to there. Amber SL source. Yeah, I know I've altered the API because I've been messing around with GLSL just to see what I can and can't do. So models, is it? Yeah, model loaders. And I want to look at OBJ loader, please. Okay. OBJ loader. It needs a loader. Right. Face structure, yeah. Where are you getting information from? Ah, here we go, the class. There it is. That's the message that we're going to get unable to open file. If I'm right, it's just going to be ... But I could be completely wrong. I don't know. Where are we? We are here. No, we won't. We'll be here. So that's going to be 3. Well, actually, no, we're not. We're going to be in here. We're in module 9. We're in module 9, and I know which level we're on because we set it under the properties, did we? No, under launch. We're in development, so we need to go to the workspace. Yeah, it's 2. It's 2. Okay, that's where we'll be. This has got nothing to do with where we'll be. So it's 2 of them. Nothing else in there, is there? No, but you can see how much effort goes in just into the OBJ loader, which has got to be changed. So that's right. I think. We might just get an error. We don't know yet. Okay, what's next? We've got ourselves a renderer. We've got ourselves an object. Let's get ourselves a texture. So, Amber. Actually, I don't mind writing in Amber at the beginning of model. It makes sense, really, in its own way. We'll go for models, colon, textured. Make a new one. Have we got one? No. So, head model textured. Head texture. That's a good word, isn't it? Head texture. You can call it anything we want, so that's what I'm going to go for. And we are going to set that. You see, we haven't got a dot because the actual head texture or model texture, the class itself, is the texture, rather than where head model is just a couple of bits that the graphics card give back. The texture has to be treated differently. So we'll open brackets and see what it says. Comma? Does that bring it up? Oh, right, yes, it does. It wants the base model and the texture. So the base model is head model, isn't it? Okay. Head model. So that's the base model. And now it wants the texture, which we haven't got. We're going to have to load that. Now, luckily, I know that loader will do that for us. There it is, load texture. It's not very obvious, is it? But it is the loader. You see, the loader is set to do a couple of things. You see, here it's setting itself to do the OBJ file, but the loader also deals with loading textures. It has that functionality as well. I'm going to go for blue. Just because I can. I think that's a texture. Let's just take our resources over. Texture. Yeah, we've got a blue. I've got a blue, gold, and terrain. Yeah, okay. Fine. That's alright, so we've got a blue one. So this splits down like this. And it's quite interesting when you see them split down, how close they start to get. Except here, we needed to tell the loader that it's a texture, whereas the loader is primarily set by our object loader here to be an OBJ loader. So that takes care of it using the object OBJ type. So that function alters the loader. Whereas here, because we don't have a function, we have a storage class only. And you have to put that here, that it's a storage class for textures. Which it is. And I'll put .png because that's the type of textures I use. Yeah, I just use straightforward PNGs. Yeah, nothing special. Anything will do them. I think GIMP I use for mine because GIMP's free. Just split that one down. There we go. Now I can't forget my semicolons. You see, it all works for me. So now you can see how this is starting to piece together. The model base to use. The type of loader to use. Yes, I went into it that deeply. And the .png name. That's all that is. That's not right there. Yes, it is. That's spot on. Wow. Some people do move that down to here. Just thought about that, but I haven't been doing it. Because we're getting an end brace there, and we're getting the end braces anyway. No, that's fine. Nothing to worry about. Where is this stored? Everything is stored in head texture. So we'll pop that there. Data is stored It isn't stored there at all. Data is stored on GFX card, comma, and class stores the ID, identifiers, and type. There we go. And there's big difference. Identifiers, the type will be a 2D texture. Because it's a 2D texture, it's just a flat piece of coloured texture that I made in GIMP. It's not a 3D texture. So we'll be using a 2D texture input for our fragment shader. That's important. Not a lot of people go into this, and it's not known very well how it works. So I'll stop here and we'll talk about it. How it works is the texture is read in using load textures, and the class texture then will place the texture itself on the graphics card, but it will also take identifications so that when we need that texture, we can send it through a special program on the graphics card that deals with two-dimensional textures, and it will then apply it to the surface of our model using the texture coordinates that are provided to it at the same time. So we are going to be providing texture coordinates. Now those are all in the load OBJ model. They've already been sent. They're on the graphics card already. So we don't even see any of that. But we have to know about it because we have to write the shaders. And it's very important. I'll show you the shader. Oh god, that's nice coffee as well. Let's just have a quick look at the shader, because I was messing around with them earlier. So, fragment please. So on here we have a uniform sampler 2D which will bring in our texture. What happens is the whole of the texture is held in there, and then we use our texture coordinates here. Somewhere down here we will use our V text coord. Actually, if I just highlight that one, does it highlight it below? There, V text coord and U texture. They are being put through a special function texture which is given by that sampler. So the uniform sampler 2D gives us a function called texture which we can then use. These clamps and stuff and pals and dots and reflect are all given by your graphics card anyway. These are all specialised functions on your graphics card that are hard-coded into chips. So they are very fast, they are lightning fast. Remember, this is going to work about 10,000 times just for this one head with the texture. It's about 10,000 times that's going to run. The fragment shader, sorry, the vertex shader, this one, will probably only run about 100 times, if that. 500. About 100 to 500. And the fragment shader is going to run about 10,000 to 20,000. Yeah, big difference. So that's how that's all working. A bit of insight for you. But I do also know that we now need to find our load texture bit back with our loader, and that is coming through models, model text, get out of the way, model textured. Okay, so model texture CPP, you see it doesn't really do much, just holds the base and the texture, that's all it does. Model texture itself does virtually nothing. Yeah, to get texture IDs, yeah. That's a little trick for the operator less than that I learnt, so I can compare two model textures against each other to see which one is less than the other. Interesting. So no, it's not in there. It's in the loader then. Dot load texture. Could be in here. No, you see, it's just doing IDs and stuff. It's not doing much. There must be a load texture in here, down here somewhere. That's a converter. That's a cleaner. So where do we do with the texture? You'll tell me in here, won't you? Where are we doing the texture? Texture coordinates here. Am I reading something wrong? Yes, I must be. It says loader dot load texture. Loader is data loader. Duh. Dum 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 dum. It's in the API. It's in here. Look at the header. Load to VAO and load texture. There you go, I found it. Load to VAO just sends it straight through. Load to texture has this. Is that a small r? No, it's not. So it's, I'm going to put in dot dot dash there. Save you out, and the other one was in here. That's capital R. Right, yep, that's saved. Done. 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 I'm not re-Ging that until I finished. I'll have to rebuild it. So we now have a head texture. We have a head and a texture for the head. Fantastic. That's really good. Can we do anything else? Like anything at all? Don't know. Whoops, don't do that. Didn't mean to do that. Let's do that instead. Model texture, head texture. What have we got? Right, so we've got the texture now. Now the texture itself doesn't read everything properly, because as we know from doing the last series, there's a lot more information in a .obj file than originally. Because of the length of the original series for Amber SL, I discounted and I ignored a hell of a lot of the OBJ file because I just needed to get something up and running, which is Amber. So I did put in here provision for a couple of little bits, and I'm going to use it. It's there to be used, so let's use it. And what this is going to allow us to do is take Amber, which is on that keyboard there. I notice you're very quiet in chat, but anyway. Mind you, you're probably watching this afterwards or later tonight or something. I might still be recording by that time. Amber, what can we have? Textures. How about model textures? Let's try you. What have you got? You've got texture. So let's put everything together so that we have a textured head. What have we got so far? We have a head model and a head texture. So let's have a textured head. Why not? So we'll set this texture up. Yeah, how are we going to do that? It's a bloody good point. Just move that a bit, please. I can't even see OBS properly here. Got so much information up. I'm not sure that's really the good way of doing it. Because we've now got this textured head. Well, we're going to have to make it equal to something. What can we make it equal to? We can make it equal to head muzzle. Right, I've got you now. We've just loaded up a texture, haven't we? So it is the textured head. We just have to add the texture to the head. So we take our head texture, and we get texture. There's only one texture for it, so there's nothing to put in there. That head texture contains all the information that we need for identifiers on that texture. So what we do is we take those identifiers and store them in the texture head. So we're building a textured head right now. Okay. So we can alter it. So what do we have in head texture? We can alter you now. No, we want textured head, don't we? That's what we've just made. Dar. Textured head dot. Ah, here we go. Set reflectivity. I'll do the shine damper first, 'cause that's the easiest. That should be a power of 2, I think. So I'll put 16. For shininess, I think it goes up to 255. But it seems to be in base 2, that one. I think it is, but don't quote me. No idea. We'll work it out in a minute or two. Let's just finish off this text. What are you up to, Muppet? Except for sitting right in front of the machine again. Let's set the other one as well. Reflectivity. Reflectivity is a percentage. So there, we'll put it to 50%. There we go. I know that one, yes, that one is base 2. Yeah, I remember now. I remember, because I had to spend a full day literally typing in random numbers and noting down what the variations were. It wasn't easy to do, so that's how I discovered, like, base 2 works better on the shine damper. So it's 0, 2. Sorry, 1, 2, 4, 8, 16, 32, 64, 120 something. You know, the rest. 28. And then it's 256. So, which is FF in hexadecimal. So you could put OX FF for maximum shininess or glass. It should work. Theoretically. No idea. Practically. There we go. If you notice, I put it in as 050 instead of just put 0.5, because 0.5 to me means a half, where if I put as 0.50, I can think of it more as a percentage, and that's usually a bit better. And I've got a cat in the way. Come on, move. Move, love. Come on. Oh, you're looking a bit weary. It's not food time yet, so come on. Come on. I can't see my screen. Cat stops play. Oh, you are a little gorgeous thing. Thing that annoys everyone. It just makes me laugh, because it's so funny. I know you want attention. I mean, that's alright. That's fine. I mean, I want attention all the time as well, you know. Dear me. Can I actually get to the screen? Come on. Move now. Move. Thank you. Thank you for the entertainment. Bless him. Can't even shout at him, really. He's ace. Right, what was I doing? Oh yeah, I was just trying to mess this lot up. Get a straightforward command. That's a straightforward command. And it should be by itself, because it is a command. That should be by itself. It is a command. And it has variables, which need a little bit of explanation, as you heard. I don't know if this is a reverse number or whether it's positive. I didn't note that in my mind. Sets the damper value for how shiny the object is. Now I don't know if that's a positive damper or a negative damper, but I think it's negative. I can't put it in there because I don't know. Sets a damper value for how shiny the object will look. 16 I find is plastic. Matte is 2, I think. I mean, test it. If you're making this program on as well, or if you haven't already done this program in the previous version when I did it in the development. It comes under the Amber Skies project development, so it must have been in the Amber Skies project part, probably one of the last videos or something like that. Most of this you'll probably find there. Value was 16. Base 2 value. I think so. It is. I think. Put it in. I think higher equals shiny. More shiny. More shiny. More shiny. Yeah, I'll put that in. And it's obvious where it's stored. It's stored in texture head. Yeah, that's okay then. Okay. Sets the reflection value. And I believe this is a percentage of light reflected. 0 to 1. 0 to 1.0. Okay. I'm happy with that. That seems fair. I haven't put anything on here. Right. I'm just wondering where Texture Head gets base model from. Or do we have to make a different one here? Oh, right. I think I might have missed something out, you know. The base model is that. The base model is used in... where? Base model is head model. That gets loaded. Head model gets used here. So that gets used here is added to the head texture. Which I'll put a D on. Okay. So that gets added in here with a texture. Everything gets stored in the head textured. The head textured then gives rise to a textured head. Yeah. So you get the head model plus the texture. Yeah, okay. That's okay, that's fine. It doesn't make too much sense. Stores everything in textured head. Is textured head a class? Okay, I'll just put stores then. Stores. Data. All data in one place. There we go. I think that's the best I can do with that, really. And gives us a textured head. Right, okay. Because that then has to be used to create something else. Yeah. All of this can be automatically done, by the way, by a program. You don't need this to be written. You can do it, write it all once, and then just put all these into variables, and what happens, you get a variable, loader. That's the whole point of this. It was never meant to be used this way. So it looks a bit weird. It's because you start with a text file that states, I want this model with this texture, or I just want this model with no texture. And that's how it should start, with just a text file that you fill in, save on a database, and load it up whenever you want, and it'll load you up a set of models. That's what it's to be used for, not like this. This is just a proof of concept, I suppose, an experiment. But look at how much space it's taking. We only started on 46. We're now on 40 lines further on, and we now have a fully textured model. Yeah. Starting to sound better than 900 lines. Starting to. But I do have some bits and pieces I want to add, because I'm like that. Alright, let's create an entity. This is what we need to create. So we've got Amber, colon, let's get an entity going. Entities, colon. I want an entity. We're going to call it head. Am I allowed to do that? It's YouTube. Yeah, of course I am. Head's head. It lives on top of your shoulders. Get your brains in the right place, Blades. Get your brain back in your head and not what you were just thinking about. Alright, entities, entity, yeah, we can have a head. Oh, right, a head is a class. What have we got? Have we got anything? Oh, we have. Oh, good. So what do we need first? Something that it doesn't want to tell us about. Alright. Amber models, model textured, model. Amber models, model textured. Textured head, is it? Sounds right. This doesn't look right. I've done it backwards. That's backwards. Oh dear. I've got something wrong with the programming. Or the think through. That's backwards because I need head textured now. I need literally the textured head, which is there. What have I done wrong? What have I done wrong? Because that's the model plus the texture. So what is this for? Is that just a storage? I think it's just a storage, you know. Because it's asking me for a model textured. Model. And that's that one there. Head textured. I'm going to put head textured in then. Oh, come on, give me the comma. At least be nice to me. Amber vec3 position. So that's amber colon vec3 position. Where should we put it on the screen? X. Put it on the right hand side of the screen. So I will put 2.5. F. 2.5 meters. X, Y, upwards, none, no, and into the screen is minus, so let's have that at -5 meters, so see how big that is. Okay, let's break this down a little bit. Okay. So that goes there. I love doing this, it's fun. There. There. And there. I mean, this has really gone way off, hasn't it? There we go. That's better. Right, that's all correct now. Fantastic. Comma. Rotations. There's 3 of them, so it's comma 0.0f, comma 0.0f, comma 0.0f. I don't want any rotations. Scale. Start at 1 and work our way down. How about that? So 1.0f. Scale of 1. Or 100%. So I'll call it 100. Yep. Okay, I think we can close that now. I think that's about right. I mean, you've seen that before, haven't you? Doesn't that look familiar? Didn't we create a matrix that looked very much like that? But now you can see there's a pattern emerging. A pattern emerging. So this creates an entity. Class to create an entity. No. I'll describe it differently. It creates an entity storage class. With a name. Which is what it does. It creates an entity storage class with a name. Head. Can't say, be specific in these things. Head textured is the model to use. That is the Amber Maths library, Vector 3D, which gives us an X position, a Y position. Bet you're glad to know these off by heart. A Z position, but you can see that it's getting easier. Here we have an X rotation. I love them when this is easy. Y rotation. And a Z. I've done that wrong. Axis rotation. Just put axis in there. And no, it doesn't mean the enemy. Ah, that was a World War II joke. It means the mathematical axis. And the scale multiplier. Lovely one. There is no scale. Right. That's that done. Looks fun. Looks fun. What do we need next? We've got a head. Still worried about this get texture business up here with textured head. Let me see if I can resolve that. Is it used anywhere? I don't think it is. I think we're using that just to set those variables, you know. Yes, we are. So that isn't doing what I'm saying it's doing. Used to set texture variables. That's what it's actually doing. It's not doing anything else. So I could have called it TH. I really could have done, to stop any confusion. Because head takes head textured, and that says textured head, and now I've got a bit of confusion. Yeah. Okay, I'm sorry, but because it's not doing anything, it's being abbreviated to that, because it's useless to me. It's a useless piece of information. It's not saying what it is, which is exactly what it should say. Nothing. Could call it T. No, because that means time usually, doesn't it? So, TH. Yeah, that'll do. Okay, so TH doesn't mean anything. Okay, that's fine. It's just a user. It's just to use. We're using that to access the textures functionality. Bad way of doing it. Why don't we just dot it on the end of that? Can't model textured. Textures, texture. I'd have to find a way into texture itself and then dot it. Is that in textures? It is. So hold on a minute. That's what I've written. That's what I've written. You can use head texture. You don't need to. It's a bit like Java. This is what happens in Java. You get something dot something dot something. Well, head texture itself, as soon as you... Head texture itself isn't in texture. Head texture contains textures. So when we get the texture, we actually move across into texture itself, which is a separate class. And under the texture class, we are allowed, because it's public, to then set the shine damper, because it is part of that texture. And even though we're only getting the texture, All we're doing is we're getting the idea of the texture and then setting the shine damper on that texture and storing the resulting head step. Yeah, that makes a damn sight more sense to me. So we actually set the damper value, sets the damper value for how shiny the object will look. I'll stay with those explanations. I'm not altering them. But I just didn't like that line, sorry. It just didn't look right. But that does. That reads right to me. If it reads right, it's right. Yep, that's the rules. Right. Where are we up to? We created our head entity yet? Yeah, we have. Oh, we've done really well. And that's only increased the lineage by about 10. Let's create the light that we can view the head by. So we need amber. And we need an entity. Get this hair off the keyboard. Entities, thank you. Do we have light? Yes, we do. What are we calling it? How's about light? And let's set it up just like before. So the light entity doesn't have a model. Obviously. There is no model for the light. Although you can attach the light to a model, the light itself has no model. Okay. As long as I got that straight in my head, I'm fine to carry on. Let's do an amber ... vec3. We'll open that up for its position. Position it at... I don't know. X. Move that over 2.5, so let's move this over 1 to the right. And 0f. Done it again in here, you know. There is such a thing as 0.00. That's in degrees, so I'm not bothered on the rotations. Okay. Comma. Upwards. 3 meters? 4 meters? 3 meters. We'll put a light bulb. A light bulb would normally be about 2.5 meters in my house up. So 3 meters is good enough. Good enough for an experiment. Into or out of the screen. We'll have it above the camera, please. So it's directly above the camera. It's 1 meter to the right and 3 meters up. So you can imagine now in your head where it is. If you look up at your ceiling and measure roughly about a meter across, that's how it should look. We hope. Anyway, so that's the end of that one. Close. Comma. What else do we need for light? Another vec3. And that's a bad amber. Amber's got a capital. We mean business. We're going to need another vec3, aren't we? Because now I want its colour. Well, I'm not going to give it a colour. So red. 0.80. 80% red. They're all percentages. Up to 6 figures, by the way. 0.80. And I can put another 4 zeros if I wanted. Comma. I'm just going to put it all... It's a white light. There you go. All at the same value makes it a white light. It doesn't make it grey. Please think about that. That's the end of that. That's a semicolon. That can be brought back to the beginning. So it's just 2 vec3s for a light. A light. This creates, use the same wording, entity, storage, class, for a light. Not with a name, just class for a model. There you go. Got it now. And it doesn't have to be 3D. Stop it. Plates. Just a model. Don't add when you don't need to. Okay, what have we got? We've got my computer working too fast. And that's what we've got. That's an X position. That's a Y position. But you can see how this is built now and why it's done in such a way. That place in a Z position. And I get a 0, 0. Okay. I didn't get my Z position. There we go. Is this better? Yeah, that's better. I'll just fill in these as well. So that is percentage of red, which it is. It's a percentage of RG, green. And the last one, notice there's no alpha value on a light. No, there isn't. You're quite right. Percentage of RGB, blue. There is no alpha channel on a light because you don't really care whether it's a visible light or not because light is a light. It's just shut those down and it turns off. If you put that to 0, your light turns off. You don't need an alpha channel to do that for you. Bit of a mess at the end. I put that on the wrong side of that. Thank you. Ambervec 3s. It's that one. Fill it all in. Don't be scared to fill it all in. There we go, that's all done then. That's nice. So we've got a light. Do we want anything else? Let's have a terrain. Go on then. Oh, let's have entities, come on. Because I want to actually play with this. So I'll do it in full. Terrain, yeah, we got a terrain. Let's call it terrain. Why not? And it's an open bracket. I haven't got a clue. It's got an XY pos. And that XY pos is part of what do you call a lot of maps together? A doobry. A doobry of terrains. An atlas. That's it. Brain, thank you for finding that word. Atlas. So it's atlas position. Yeah. I'll put it at -1. Yeah. Why are you not putting it at 0, 0? Because minus is into the screen. -1, comma. Yeah, -1. It's an integer position. So if you have an atlas, this is the square at -1, -1, where 0, 0 is that square there. You get the idea. That's your 0, 0 square. This one's the one up to top left. So if you've got squares, this one's up there by 1. This is the next square up. That's how you do maps. You do them as an atlas. You have to make an atlas, a class, and you store all your maps in it. Usually on disk, or well, file names in it for your maps. Well, however you want to do it. You know the things. What have we got here? We've got a loader, so let's give it a loader. We've got one of them. Oops, not hash. What else do we need? The terrain texture. Whoa. Yeah, right. Loader dot. What we got? Load texture. Terrain. That'll do. Split that down. So that's your terrain texture. I think I've got one called terrain. Just check. I have. It's greenish. There you go. Of all colours, I made my terrain texture greenish. There you go. Bless. Do you need anything else? Really, for a terrain? So we've got its location in the atlas. We have given it a loader. So it can load something up or make something up. I don't know how it's doing it. Load texture. Gives it a texture. That's it. I think we've got enough now. I think we've got enough to make a scene. Yeah, we have. Why have I got a spare one of these? Don't know. Can't remember. Alright, I think we can make a scene out of that. I remember the time my mother made a scene at Tesco's. It was all about the price of an apple. No, I'm drifting. Come back here, Blades. She says she wasn't going to pay for the weight of the caterpillar. Alright, it's a bad joke. So, how are we doing it down here? God, we're right down the bottom, aren't we? Wow. We are adding lines. We're over the 1,000 now. Yay! We got to the 1,000 mark. How are we doing it here? We're doing that, are we? Alright. We'll do that then. All of that code has now been brought into not a lot of lines. So, what have I actually done? I've taken 900 lines of code and I've used Amber SL, which is my own SDK, I suppose, development kit for 3D that I wrote myself. We're getting there now. We're nearly there. And we've done it in 60 lines. And then we have our main loop. There we go. Oh, stupid me. There we go, we did call it the window. You see how small this is now in comparison. So that does 900 lines of code minimum. There's probably more lines of code in the background happening as we speak. So while the window ain't closed, simple check for the user requesting the window to close. That's correct. I think we will have that. Alright, what we're going to do. We will have a camera. Dot move. And we will place in here the window, because we have that function available to us. Don't know why I just did that, because we're not supposed to do that anymore. So let's simplify that. Check for the location of the camera in case it moves, and the window to use for the camera. I'm not sure that's a check. Check for the location of the camera. Check for the location. Well, that's what it does actually. Checks to see if it's moved. It's an if statement in there. That's fine. It's just using, it might be using the arrow keys, or it could be using ASDW. I honestly don't know. I can't remember how I programmed it, but it's easy to find out. You just run it. And I don't think we had mouse capability of right click and turn implemented in there. If I remember rightly, I didn't want to do that at that stage, because that increased complexity. So, for testing, we will take our head. God, that does sound so bad. We'll increase something, shall we? What have we got? Rotations we were doing on our original test. And we're doing the X and Y position. And we were doing 1 degree, weren't we? No, we should be going at a frame rate which allows for 1 degree. 60 frames a second. Should be doing that. What am I doing? You see, I really need to get back into this habit. It's going to kill me in a second or two if I don't. So it's 1, 1, dy, dz. Yeah. So d, I use a mathematical d for delta, which means change. So change in x, change in y, and change in z. So that's actually a message to me. In other words, we're doing rotations around those axes. And the change in the z-axis is 0. Yeah, we're only doing the x and y. That's all we did on the last one. I want to see if it does it properly, or whether it goes around the wrong centre. That'll do. I'll do you. Let's note that up. It's a test function for rotations. Can be. I'll probably leave it in actually. That's rotation around the x-axis. The y-axis. And the z-axis. Simple stuff. Okay. And of course that will change the way the MVPs work. And it'll do it for us. I hope. Yes, it will do it for us. So what do we need our master renderer to do? Master renderer, what can you do? Oh, we'll process the terrain. What do you need to do to process the terrain? There you go. That. Yeah. Yeah, that's it. What that actually does is that adds the terrain to the list of things to render. Yeah, it doesn't actually do much. It just takes the terrain data and it just says, oh right, we're going to be doing that this frame. we're going to be rendering the terrain. You don't have to render the terrain every frame. You could do it every second frame. Save yourself a lot of hassle. Would people notice that they had a 30 frame rate on their background and a 60 frame rate on their foreground? I'd like to test that because I've got 2 windows coming up. Yeah. So what I want to do is put this window behind the other one. That'd be funny now, wouldn't it? See if that can be done. So, we've processed terrain. What should we do next? Master renderer. What else can you do? Dot. Process an entity. Open brackets. What entity shall we process? Head. Why not? That's it, folks. Would you get off me, computer? Thanks. I'm going to put that there. I haven't done that line. Yeah. Now it means something completely different. Remember I said it was -1, -1? Well, I could have checked which part of the atlas the player was in. And if the player was in on map 10,20, I will put terrain 10,20 in. Yeah. That opens up multiple terrains. Wow. So you can see how it's been programmed to be expanded. Same with process entity. You can put any entity you want in here. Because what does this do? This adds an entity to be drawn this frame. Doesn't really do much. Done that again. And that's the entity to add to the list. That's what it does. So we've added the terrain to the list of things to draw, and we've added our entity to the list of things to draw. What do we do? Master renderer. What else can you do? Dot. How's about render? And how do we render? We need light. I call it the sun. Just an open invitation to call it the sun there. So, nice one. What else did we need? We need the camera that we're going to use. The light and the camera are for, one, in the future I want to do shadow mapping, so the light will need. We also need that for where it is and the lighting equations in the shaders. The camera is the viewpoint, where we view where we view from. So that holds a very important matrix. Notice there's no maths in here, none whatsoever. All the maths is hidden in here, really. A lot of the maths is hidden in this one thing. But I can now semicolon that off. It only needs 2 things. You see, the actual render doesn't take entities or terrains like a list of them. That's already done. That can be done in a separate file. A totally separate file. Or from a totally separate file. Or from a totally separate program, I guess. As long as it can be communicated. I'm doing servers and stuff, aren't I? Interesting. Render. So, rendered. What we're going to do now? Well, we'll take our the window. Take our the window because it's slightly different, and we're going to dot update. Window has a ton of stuff in there. We'll just update and carry on. When we've finished, we exit. So we don't exit here. Okay, that goes back then to the main. That's all there is. That's it. 100 lines of text instead of 1,000. So a tenth the size using Amber SL. A lot more straightforward. and I haven't finished. Draw the scene. Full stop. Using this as the sun and using this as the view point, because it's a point camera. It's not like a camera with a lens or shutters, although you can make those as programs and do that. It is a pinhole or minute point. It's one pixel big in that camera. Well, it's not even shown. So there we go, window update. Anything else we need to do? No. Just return 0. That's a good point. So we stopped it at our... Alright, this is all the doofries first. Doofries. I was going to take these out and just stick them in a separate file so I could do this easier. Here we go. So I don't really need... Yeah, I still need the window. I could do the window first. Instead of doing all of this. I could move part 4 to part 1. No, I don't do it that way round. I always do that part first before putting the window up. It's dangerous otherwise. You can start drawing to windows that aren't on screen and all the rest of kind of rubbish can happen. And interruptions can happen on the window that you don't know about from the operating system. So I like to keep it a clean start, as it were. Separate exit condition, so exit 0, yeah. It's return, isn't it? Yeah. And that's just return 0. I hope I'm right. So I'm about to test it. Let's see if we get it right. There is something I do want to do as well. Close everything, please. Thank you. Module 1. Amber SL. Exec. I just want to put in make clean. Thank you. And now we can do a terminal on that. So now we can do run a build task. We can do it on module 1, please. Thank you. That's the whole build and nothing but the build. And I've run out of coffee. Okay, looking good, looking good. How long have we been on for now? Oh, we're into 3 hours. We're doing well. Doing good today. I knew this was going to be a good day. So I knew I got to change Amber Sky, so it started to work in this development area. So this is my testing for that as well. But as you can see, I had to use a texture and not the same code or model. And that's the difference. We need to be able to convert the code so it's introduced into Amber SL and can do the same model 2 ways. Okay. Do I want to continue on and do... No. I'll try this first on true. Do I need anything No, I don't. Just run it. See how many errors we get. Unable to load shader. Okay. GL compile shader failed. Good. Oh, got to close you, haven't I? Oh, alright then, close you there. Thank you. That's in Amber SL. There's your data loader. There's your shaders. I didn't think I'd have a shader problem because I didn't move them. But I'm now here, aren't I? I'm not here. I think I've got to move my shaders. My GLSL's going to have to move. Damn. That's what I didn't want to do. I was going to have a static set of shaders. Interesting. Just try faults. Make sure everything still works. And that those shaders aren't being triggered. Works perfectly. Now all I've got to do is find those shaders. Right. So we're in Amber. OpenGL. Shader Foundation, CPP. Load. ... Lemon sand. How am I going to do that? I'll move them to resource. Anybody know what file name I'm using? No. Comes from Shader Foundation. Oh, no. So it'll just be a file name, basic or something. Right, I've worked it out. Okay, that's fine. All I need to do then is change that to ... Okay. And this will be resource. And I'll have shaders. And we'll copy GLSL into there. Yeah. That's what I shall do. Copy our shaders into the resource and see if we can pick it up there. Linking programs. Yeah, let's just see a failure point, which was good. I'm glad I put the failure points in now. Let's have a look. We have development module 1. Source, API, GLSL, copy to resources, shaders. I've already got some, so that's why I added the folder, so I didn't mix up my basic ones, because there's now 2 sets of basics. Shader Foundation looks okay. We now have to redo it. So open terminal, make clean. Alright, excellent. just recompile that with the correct pathing. I hope it's the correct pathing. Seems to have worked with most other things just by doing that, so... Yes, I know, I guess at things. I know. Oh dear. Blades at work. That's a joke in itself. Oh, right. Thank you. Thank you. Thank you. Let's see if alterations help. Damn it, I left it as false. Okay. Thank you for that. True, please. Let's run that. Dum 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 dum. Ooh, something happened. It looks as though it started out on it and crashed back out. That was interesting. Can we move? Oh, yes. I now know it's not doing what it's supposed to. Good, bash. Thank you. Here we go. This is what I want to see. Welcome to Dev Center. La 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 la. Unable to load shader // resource shaders glsl static shader .vs. Okay. I got that up. No, I haven't got it up. No, it's not up. It's him. So resources, it's that one. Shaders, plural, is that one. GLSL capitals is that one. Static shader with capitals is that one. We need an extra dot maybe. Interesting. Oh. Use that. Have I got anything that's silly that's still up and running? Yes, I have. These are running in the background. Any other background messages? Yep, still got one running there as well. Okay, any others? God. No, thank God for that. Right, that's all cleared. So we're going to have to try again. I'll keep it on true this time. We'll just get rid of that. Close that. And we'll go back to... this one. This is where I'm stuck. I'm going to try another one of them. I think it might be 3 up. Perfectly viable. It's on a CPP, so that's fine. Terminal, run build task. Number 1, just that one please. Foundation, thank you. And now we can just go straight over and run our test. No. Oh. It didn't change our test. That hasn't recompiled. Oh, I didn't realise that. My bad. Test. Ding, ding. Test. Didn't recompile, you little devil, you. Just open you then. Open terminal. And make clean. See how you got to watch it on these? Try that one. Except you've got to be very careful that doesn't happen. Nothing to be done. Of course there's nothing to be done. Let's try again. There you go. That's now doing something, because we cleaned it all up. That's with 3. And then across the resource. exe main, outside main. Could be 4. Sugar. No. Exec up 1 is amber. Up 1. So that's the first. Up 1 is the first one. Dot dash. Dot dash. The second one is amber. The third one gets us up to module 1. And then we need to go up above to the next. Yeah, it's 4. Sugar. For it be. Don't believe this. I don't normally have this much problem with these. You're done. And let's go. And it still can't load them. Bugger. There's something wrong with the pathing here. Something drastically wrong with the pathing. And I'm thinking that it's going from PWD. And that's the only other alternative I know of. Because I've counted it all out now. So there's only one other option left. And that is that one. I've spelled resource right, haven't I? Please say I have. No, I haven't. God damn you. You see, all I have to do is check things properly in the first place and it'll work. It's 1 up. I'm in the command directory, so if you're in your own command directory, then you are on the flat. The exec is below you. So you go up 1, up 2, sideways 1. I'm sure that's right. Plurals. Yeah, okay. Come on. There we go. Thank you. Task 1's behaving itself nicely. And doing what it's asked. So it's either 2 or 3. I know that. terminal. And go. There you go. Loading, unable to open file. Dot dot backslash dot dot backslash resource obj head dot obj. So this is a similar situation, but with a different part of the file. I put 2 on there. Okay. I'm gonna keep. Oh. Right. Okay. We seem to have 4 bashes going on here. That's fine. So pop this over there a minute. I'll keep it running so I can see it properly. So it got to loading the OBJ file and then couldn't find the resource. And it's not pluralized there either, and that's why. So yeah, just close everything down. Thanks. I know what's wrong. I already know what's wrong. This is creating a hell of a lot of these. No idea why. Stop it. Don't want all of these. Don't want you to keep repeating them. Stop it. Right, we're back to normal. Okay. Jesus. So it's only an error now, not in our code. So that does matter, yes. It's in module 1, AMBSL source, and it's in models, model loaders, there. Resource. Yes, please. And that should do it. Yeah, typos. That's all I've got. Typos. Okay, you're done. You're done. Shut down. Again, I've got to keep doing this. Unfortunately. Otherwise it won't compile fully. So I have to keep doing the make cleans to make sure it does a full compile each time to alter the pathing within the code. Okay, we're running. We're waiting. Doesn't seem to be giving me too much wrong. Well, not on that screen anyway. What's on this screen here? That was the last one, so that's done. Oh. It's got a memory going on somewhere. I haven't asked it for. It's memorizing the last versions. Interesting. Never seen that before. Shut down. Hi, Office. Oh, that's a bash. Don't want a bash. Where's my consoles gone? I hope I haven't made a complete utter hack of it. Discard that. Open that. Open that. Right, that's me cleaned up my windows at the same time, so I've got the right windows on. Well, hey. And for all the people watching, I know that you're watching probably in the past, because obviously we're well into the stream now. I wasn't going to wait 3 hours for people to join in. What I'm doing now is just really banging my head against a brick wall, which is what I always do when I'm doing these tests. So at this point, I think I will go off camera because I'll do this tomorrow actually. Get this working tomorrow. I prefer to think about things. I know that there's something wrong with the resources extraction, but the resources, it went for OBJ. I don't think it was capitalized. So I've got to match these up properly. I mean, that's what it's really saying. It's saying that I'm being an idiot. That's what it's saying. I didn't even look at it, did I? You see, that's in lowercase. Resources is... yeah. It's resources, alright, but it's OBJ in capitals. See what I mean? It's just me being a numpty. There we go. That's what it should really be. Darn it. I'm just not slowing down and going at my normal pace of like a tortoise. I think it's because I'm under the pressure of being on stream and also chatting at the same time. Doesn't help. But hey, quite happy to get it wrong for you. Doing a bloody good job of that. So there you go. I can do something very, very well. And now you know what it is. I'm not a programmer by any stretch of the imagination, so don't get me wrong. I'm not claiming to be a programmer. I'm just somebody who makes difficult things look easy until I decide not to read what I've written. You know, that kind of thing. I'll just keep this open now, 'cause it's picking me off. Here it is. Textures aren't there. That's the object, it's just not got the textural light on it. So that's what I expected to see. There we go, on a clear background. Yeah. I haven't got a clue what this is here. Is it from the I'm GUI? Is that something happening in the background that I'm not aware of? Probably. This texture isn't set up right. That's fine, I don't mind that. But look at the way it's spinning. It's doing the same thing. I think there's something wrong actually with the code. That's what I wanted to test. I'm not really bothered about the texture or anything. Told you there's something wrong with me code in that. Yeah, ho-hum. Things for me to look through. So not everything's working perfectly, but you can see that it is going to do what it's supposed to do, because obviously you just fix it. Where are we? So that was a quickly written 1 hour episode of writing a 3D program that puts a black thing on the screen and swirls around a bit. It looks quite interesting. So that needs a bit more development on it, which is fine. I don't expect everything to work first time. In fact, I expect nothing to work first time, ever. So I can go back to faults whilst I sort it out. And we should still have our original starting point for the day. There you go. Just get rid of VS Code from behind. And there we are. It's now 4:45. So there you go. It's a real clock. We started this 3 hours 40 minutes ago. And we've gone through a journey of looking at all of OpenGL. We've sat and talked about a few lines of code which other people will ignore. I've literally been through all of this now, top to bottom, except for the I'm GUI stuff, which I'm still uncertain about. And I've added some checking code about this weird kind of thing that's going on. And I think it's because we haven't dropped it by half. I think we should have dropped its location by 0.5, you know, to put it in the center of the world to start off with. It's not getting to the center of the world properly. When you draw an object in OpenGL, you have to draw it at the center of the world. The matrices that put it into the world itself operate on it in a sequence afterwards. So that's why we have the MVP, model view projection matrices. And that's how the final X, Y, Z coordinates of your model are determined. Now that model is directly in front of me. So it should be having the center of it at the center of the screen. But for some reason it doesn't seem to be doing that. Which means one of the equations might be out of order. You see? That means I've got to go equation hunting. But I'm going to think about this first properly. Because it does look as though it's offsetting itself. I know it's 0.5. Because I can see it's 0.5. I can mathematically see this in my head and reproduce the effect. So I know the answer is 0.5. I just don't know where it is. Isn't that interesting? Yeah. Oh, I've actually got an error. Because I use a 0.5, I know on placements. But what have I used a 0.5 for? No, I haven't done it. I didn't think I had. I hadn't placed this because normally I would place this at half its height. Now this is a 2 meter object, so it would be in a y of -1. It's a 2 by 2 cube. I know it is because I drew it. So let's put it on the plane. Nope, that's still not working. In fact, you can't see any difference in it at all. That create model matrix isn't working because we've got a separate create model matrix here, cancelling it out. That one's the one it's affected by. So I don't actually need the initial create model. Yes, I do. But these have to match. -1. Thank you. Glad I've got a brain. There is a visual difference in the two. That's where it should be. No, it isn't. I haven't scaled this down. I need to look at this model in Blender. And that's the start of tomorrow, I guess. We're going to hunt the model weirdosity. If you do know the answer to this, it might be that this model has to be centered properly in Blender before exporting or whatever. I don't know. Problem is I've got a version of this working with this model. And it's using exactly the same code. And I mean a direct copy of this code, and I've got that going diagonally. Isn't that interesting? So something is happening, whether it's on the graphics card or somewhere, but that is wrong. Something is messing about with the program. So it actually could be just my machine. That'd be interesting. My machine handles OpenGL differently to anybody else's. But that should put it in the center of the screen, not below the center of the screen. I'm sure about it. But I'll have to go and learn how to use Blender to find out. There we go. Things to think about. How have I cocked it up? Because I've done it. I've actually cocked it up. And I know that the code's right. Well, up to a point I know that the code's right. I'm going to have an interesting journey now following my code back through. Because it's only a straight line all the way down. So it's easy to follow. It's just a line of garbage. Commands, sorry. C++ commands. And I've put all my markers and indentations in so I can check everything off to be correct. And all I have to do is start at the top and work my way back through it. But yeah, that's an interesting thing that. We started at line 34 and up to there is the whole program for Amber SL with lights and terrain, which is why it's not working properly. But anyway, I'll jiggity jig that. Means it probably isn't picking up the textures right, is it? Because I haven't put resources plural on the textures. I mean, that's all it blooming well is, most likely. So it's just eek, irk, ark. You know the kind of thing. Where's textures? Oh, is it in loaders? No. It's in there. There you go. S missing. It's just not picking up the textures. That's all. Run build task. Run build model 1. Please, Bob. Make sure on development we are showing true. I need a bigger mouse wheel. It's a joke, by the way. It's supposed to laugh. No, you're not. Yum, 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 yum. Yeah, that's okay. That's okay. I might just have a 1. Bet I've got a decimal point somewhere in the wrong place. Knowing me. Here we go. Open the GL window. True. That should force it to recompile. Is all I need it to do. Oh, got some black burpy liquid here. Oh, that's the terrain. All right. There you go. It's got a texture on it. Just look at that lighting, though. Put it up full for you. There you go. That's the terrain. The terrain needs shifting over, or the camera and this object needs shifting over onto the terrain. No idea what that blue is back there, but anyway, I don't care. I haven't been messing around with the terrain too much. Don't tell me it was height mapping the terrain. No, I couldn't have been. I'm not that stupid. It's got a background though. Look at the glittery glossiness of that. That texture is beautiful. That lighting is wonderful. It took me ages to simplify out the lighting equations to that stage where it became fast enough to be instant. And remember, I ain't got a graphics driver running. So there we go. Written in an hour, a 3D engine picks up and throws a model on screen. Fantastic. quite like that idea. I don't think I should have bothered with the terrain. Never mind. That needs sorting out. Mind you, the terrain always needed sorting out, but I just never got around to doing it properly. As you can see, it just stops. And it still thinks he's got a background going there. Okay. Yeah, right. I don't mind. I don't care. Yeah. Interesting. I'll show you why that is interesting. With a very little bit of messing around. You see, it's easy for me to mess around on this top part. For a big reason. I know what it's doing. Because I wrote it. So, if I take the light entity and leave it where it is, that doesn't really matter. It's gone in 5, right, so if I make that into a minus 2.5, where's our camera? Set position, minus 3. 2.5, yeah, minus 3. So we're going left, basically. We're taking the whole scene and we're shifting the scene to the right, us to the left. What actually happens is we shift the scene to the right, in reality. But don't tell anybody. That's a secret. That's a trade secret. If I run it now, the camera will have moved, and so will that. The light will not have moved, so that will look different. The terrain will not have moved. Could be interesting. Let's have a quick look, see what I did. You can just play around with the variables and setting things in different places. There we go, that's what I expected. So I know now that half of that object is below whatever mess I've put on the terrain. It's got part of the blue thingy on there, that's lovely. I better put blue on the terrain. Oh, never mind. Doesn't matter. Yeah. Very interesting. Very, very interesting. But the terrain's actually correct in size. It's just bleh, all over the place. Works. To a point. Right. I'm going to go and let you get your tea. Because I'm coming up to tea time now. I need to stop, take tablets, take a lot of painkillers because I'm in a lot of pain, and go and get a bath and do my medication tonight. It's Wednesday. So if I'm not on tomorrow, don't worry about it because I've got big medication night tonight. But in the meantime, take care. You know, keep messing about with code. And above all, have fun.